Hello, welcome back to our series, Behind the Scenes of Nautilus. I'm Commander Brad Boyd, Director of Submarine Force Museum and Officer in Charge of Historic Ship Nautilus. This episode, we're going to push back the going into the sail and up to the bridge, and we're actually going to do the escape trunk operations, because I had a few questions from our previous episode with going under the superstructure on how exactly escape trunks work. So we'll go through that, and then next episode we'll go into the sail to the bridge to wrap up our series. So if you have any questions, please let us know. With that, on with the tour. All right, so you may remember this from a previous episode, probably the second episode where we came in the torpedo room. This is how the weapons got into the ship, so that's the hatch to the outside right there. It would come down that slide, and then they would come out this hatch here. Now, when Nautilus was in service, there had also been a ladder attached right here, and this double-dutied as the escape trunk. That hatch would be shut up to the torpedo tube, and then you can see in here, and we'll go in here in a minute, you go on up into the actual escape trunk, and that's how they would actually get out of the ship. Now, it's a few operations have to happen, so you've got gauges that you right here that you can't see too well. But these gauges do things like tell you the sea pressure, the pressure in the trunk, the air pressure going to the operations so that you can operate it. And then you have a series of valves over here that help you actually operate the valves inside the trunk, as well as allow you to close the external hatch from inside the ship so that you can cycle it after one set of people escapes. Usually go up in groups of two. You can get to the next set in. So that happens outside the outside the trunk. With that, we're going to go into the trunk, and give me a few seconds as I climb on up here, and we'll go from there. All right, bear with me as a second as I climb up on in here. So as I'm coming in, first off, we'll start with this. You can see up into the weapon shipping hatch a little bit easier now. So that's the skids that the torpedoes would be loaded in on, coming through that hatch, then coming back down through this hatch here, with that hatch as the closure. So that's what that is. And then this part here is the actual escape trunk. So just getting in here, and we'll go over more of it. All right, so up here is the actual hatch. So that's top side. I'll show you the hatch when we get to top side and where that comes out. But they would verify that that's shut. In fact, there's a procedure for all this over here. In fact, I'll go around the room real fast and show you what's going on first. So you've got, excuse me. You've got your water inlet valves over here. Then you've got air connections over here. So this connection right here that you see, that's kind of our standard emergency air breathing mask connector. So everything kind of works in with that. And that way they can plug it into, in this case, they would have had what we call the Stanky Hood, named after Lieutenant Stanky, who invented it. That replaced the Momsen lung that would have been used in World War II to assist you in breathing all the way up to the surface. But the Stanky Hood, you would charge it up so that it has a flotation device with it, and then the other flotation devices you may have charged up as well. But you would charge that up with high pressure air, and then you wouldn't charge your own breathing part of it. It's just the life jacket part, and then you would have the hood to pull over, trapping an air pocket, and that's what you would breathe as you go back up to the surface. And we'll cover all that in just a minute. You have gauges in here, so this tells you what the charging pressure is. So your air pressure is coming in. That tells you what the pressure of the trunk is, and that tells you what the sea pressure is on the outsides, because you have to equalize pressures to be able to open that hatch. At 4.44 pounds per square inch of every 10 foot of depth, that adds up quickly, and you can't move. You know, if you have a hatch that's about what, 20 inches in diameter, so 10-inch radius, so 300 square inches. You had 4.44 pounds per square inch. That adds up real fast in pressure. So you have to be able to equalize to get across that. So you have all that. You have a mechanism here so that you can connects down to that handle at the bottom that we talked about. But anyways, that's the remote operation for in here. And then you've got over here is the actual procedure. So I'm not sure how well you can read it, so I'll read it off to you. First is put on your escape appliance, breathe through the snorkel. So that's the in Nautilus' case. At the very beginning would have the Momsen lung. At the end would have been the Stanky Hood. And then you have check upper hatch dog close. That's right there. You can make sure it's dog close, because as you equalize pressure in here, you're actually gonna get to the point where you're hopefully just slightly above sea pressure, and you don't want this thing to crack open before you're ready. So you make sure it's dog shut. Then you're gonna undog the side escape and open the hatch closing line. So that's the closing lines are over here. So open your closing line, get your 100-pound and life jacket charging manifold regulator valve at 100% PSI differential. So basically you're gonna make sure you're about 100 pounds above sea pressure. And then you open the flood trunk, don't increase your pressure. Ventilate the trunk by cracking open the blow valve. Shut the vent and inflate the escape appliance. So that's whatever device you're wearing. So probably the Stanky Hood for most of Nautilus' life. Pressurize the trunk rapidly, because you don't want to continue. You don't want to subject yourself to pressure longer. The longer you're at pressure, the greatest the chance you'll develop nitrogen sarcosis with the bends. So if you have a momentary increase in pressure and then go back into atmospheric pressure at the surface, much less chance of having complications. And then breathe normally while you're doing it. And then exit the trunk. So when the trunk is pressurized, take one full breath, close your snorkel off, and remove it from your mouth, and unsnap the quick disconnect coupling from there. That's the quick disconnect couplings. And then you're going to exit the trunk immediately and continuous breathing. So basically you're going to breathe out all the way up, so that as the air that you took in under pressure, your lungs don't, rupture effectively as the increased pressure differential between you and the sea pressures you go up. So you breathe out the entire time so that you don't blow out your lungs. Then you also have escape tap signal, so you can't talk to anybody while in here. So you use a hammer on top of the hatch, and this hatch is what would shut over that opening there. And you use a hammer, so one tap means that your pressure is equalized, the door open, passage, and your outside hatch is clear. 2 taps means that you're leaving the trunk. 3 taps means the last man of the trunk is leaving. And 4 taps is, hey, something's wrong. I desire to return to the room, so we're going to drain the trunk and try this all over again. So that's your tap signals. So, okay, so that's how you use the trunk. And then you've got, it could also be used for normal passage, although most likely not for the boat. That would have been through the wardroom and through the sail, than the normal passageways in and out of the boat when she's just in port. So I mentioned the fact that there are different ways of breathing. So Momsen was somebody who invented the first escape apparatus, and what this does, what it was it's basically a little leather strap, as I mentioned, that goes over the neck, and then it's a bladder that's held in front of you, and then you put the snorkel or the mouthpiece in, and that helps you just recirculate your air. Once again, it lets you breathe just a little bit longer. You're not trying to do this for long prolonged minutes or anything, and then helps you concentrate as you breathe out, so you don't succumb to nitrogen sarcosis. The Stanky Hood replaced that because it involved an actual flotation device with you, so that you could be pulled towards the surface as well if you became immobile going through the hatch, hurt yourself, or got disoriented as which way is up. You can, when you get into the water, you could then, the buoyancy would help you figure that out. And then nowadays we use the Psi suit. And so what that does is it's a full suit that you charge with air. You still breathe out all the way up, but then it helps protect you from the elements once you get to the surface. So, submarine escape is not the desired methods of leaving the submarine. Obviously, coming back to the surface under normal power is the preferred method. But if you get disabled, you'd rather be rescued. And there's multiple ways we've done that. It was a diving bell. We went to the DSRV, Deep Submergence Rescue Vehicle, and we're kind of back to the diving bell. The Deep Submergence Rescue Vehicle was great and all, except for the fact that it required battery power to operate, so you had to have you still had to have a surface vessel support for the most part to do prolonged operations of it. And you could get on scene just as fast with the diving bell, and you could actually do more trips with it. So we went back to the diving bell. And what that'll do is it'll hook up to the collar on the outside, and then you just transfer people into it, depending on the size of the bell, 10, 12, 13, 14 people. will go at a time. It basically becomes like an underwater elevator. It just goes up a cable to the surface ship, they unload, and they come back down, do the exact same thing, and just slowly evacuate the crew that way. That is the most controlled way to do it. If you can't wait that long, or for whatever reason they can't mate up, then you have to evacuate the submarine via the submarine escape, and that is dangerous. You've got to, you know, pressurize yourself up. You've got to clear the hatch. You're gonna have positive buoyancy. You can hurt yourself going out, and if anybody gets and fouls the hatch, everyone below is trapped. So it's not the preferred method. But and then on top of that, if you go up and there's no one up there waiting for you, you still have to deal with the elements. So not the preferred method, but it is a method off if you cannot wait for rescue, or rescue is impossible based off of angle that the ship settled or what happened, whatever random thing happened. For the most part, it shouldn't be an issue, but it's there for rescue to be able to come get you. All right, the next part is, have we ever used the escape method? So we've rescued via diving bell. The first one was a squalus. We've only done one ever successful escape from a submarine underwater without a rescue bell, and that was from the Tang in World War II. So the USS Tang under Dick O'Kane was in the middle of a battle, and they're on the surface, and they fired a torpedo, and it circled back and hit them. Dick O'Kane and 3 others were in the bridge, either blown overboard or dove overboard after it hit. Everyone else was able to move to the torpedo room area, and then of that, about 30-some people, 13 attempted escape. Of the 13, 9 made it to the surface. They don't know what happened to the other 4, and then of those 9, 3 weren't able to hold on to something that was floating and couldn't swim long enough for rescue and drowned. So only 5 were actually picked up by the Japanese and then spent the rest of the war in a POW camp. So, but that is the only time we have ever actually escaped from a submarine that had without the use of a diving bell. So, but we still maintain the ability to this day. So, okay, so that is a escape chamber. Forward escape trunk for this one. There's 2 onboard Nautilus, one forward, one aft. I'll show you both those hatches when we go topside. But with that, we're going to go back down and out, and I'll see you guys topside in just a second. Bye. All right, so we're topside, just to show you. So this would have been the escape trunk from the torpedo room. That's the weapon shipping hatch. That's where the torpedoes came in, and then that's the actual escape trunk right there. One of the questions we had was other ways into and out of the ship. So from right here, this is another hatch to get into or out of the ship. This goes into the wardroom. Now it is not an escape trunk. You couldn't use that in an emergency to get out, but that's just a normal access point. Another point is right here through the sail, which we'll go into next episode, and that's how we're actually going to get up into the bridge. That'll take you down to the control room. And then you had a couple other hatches as we go back. This right here that we're coming up on, that's the other escape trunk. So this is the aft escape trunk. So you've got that right there. That's the aft escape trunk that you could either connect with the diving bell connector that would mate with that right there, or you could have the free ascent, the ascent via someone inside. And then I do not know for sure, because I don't have a schematic that shows this or not, if this would be another entry point. I believe it was, but this would have been an entry point into the engine room through that hatch there. So one other question we had was what exactly this structure is on the aft of the sail. So we'll talk about that real fast. So you've got this, what looks like a handrail. That's exactly what it is. So these stanchions that you see here with the cabling that goes across would not have been there. This is welded in. That would not have been there when Nautilus is in service. This is put up as part of the museum. We're not going to go underwater anymore. I don't have to worry about a streamlined hull, so that wasn't have been there. This was a handrail, so that if you have to walk from the sail and go aft, and you're trying to scoot along right here, you can see relative size. So that's my feet trying to stand there, trying to scoot by. You may want to have a handrail to hold on to in case you roll just a little bit, and you're less chance of falling over the side. So that's what that is. then that, by the way, that is the ship's whistle. So that's where and whistle, it sounds more like a big foghorn, but it's called the ship's whistle, and that's just high pressure air that goes through that to cause the loud sound. Now, one other thing that I've been asked about is the cleats. So these cleats here are rollable, so that way you can actually streamline the hull a little bit better. And these cleats can roll over and go inside and turn around, so that you can hide them inside the deck, and therefore not have a flow disruption. Streamlining yourself, making yourself a little quieter. More importantly, making you a little bit faster, as you have less drag underwater from that. Same as these cleats here. So those cleats are rollable. Those cleats are rollable. So, all right, as I said, next episode we're going to go into the sail. And I hope you guys enjoyed the tour today. If you have any questions, please let us know. But with that, bye.